Until now, every model predicted a continuous numerical value. But many real-world problems require a different kind of answer. Sometimes, the prediction is not a number, it is a category. Classification assigns observations to predefined categories. Instead of predicting a value, the model predicts which class an observation belongs to. Could we just reuse linear regression? Let's label spam as 1 and not spam as 0, and try. Linear regression can produce predictions below 0 or above 1. These values cannot represent probabilities. For classification, we need predictions that always stay between 0 and 1. Logistic regression solves this problem using the sigmoid function. It transforms any input into a probability between 0 and 1, making it ideal for classification. Despite its name, logistic regression is a classification algorithm. It first computes a linear score, just like episode 2, and then squashes that score through the sigmoid. The model estimates the probability that an observation belongs to a class. Each suspicious feature pushes the probability higher. If the probability exceeds a chosen threshold, the observation is assigned to that class. In feature space, the model's threshold becomes a decision boundary that divides the plane into regions. Observations on one side are predicted as one class, while observations on the other side are assigned to the alternative class. The boundary itself is exactly where the model's probability equals 1/2, pure uncertainty. During training, logistic regression adjusts its parameters to improve probability estimates. With every iteration, the model becomes better at separating the classes. Let's recap. Classification predicts categories, not numbers. The sigmoid squashes any input into a probability. A threshold turns that probability into a decision, and in feature space that threshold is a decision boundary. Logistic regression is one of the most widely used classification algorithms. It powers applications in healthcare, finance, manufacturing, cybersecurity, and many other fields where accurate binary decisions are essential. Logistic regression creates a mathematical boundary between classes, but another powerful algorithm makes decisions by asking a sequence of simple questions. In the next episode, we'll explore decision trees.